let's discuss the answers for this sample problem or sample activity from your book. This is on page 5. Here, identify the types of intermolecular forces between the following pairs of molecule. First, we have H2O. So we have H2O. This is composed, of course, we have H2O molecules here. The first step is to identify whether this one is polar, nonpolar, or ionic. Now this one is polar, so we have discussed why this is polar in our previous lessons. Again, this one is, its shape is something like this. So the electronegativity of oxygen is 3.5, hydrogen 2.1, 2.1. So here, the oxygen is partially negative. It's more electronegative. This one is partially positive, and this is also partially positive. And the same thing for this another H2O molecule here, the same polarity, partially negative on oxygen, then hydrogens are partially positive. Now here, what is the point of attraction, or how are these H2O molecules attracted to each other? So this is the part, so this is partially negative and this is partially positive, yung hydrogen. So this will be attracted to each other because of the opposite charge. What type of force is this? So by that we can look into what type of molecules are this. Again, these are polar molecules. This is polar and this is also polar. Again, we refer polar here as dipoles. So dipole, then dipole. Then to name the force, just name what type is this one. This is dipole and this is dipole. So this one is a dipole-dipole force. But here, take note that this hydrogen is, this one is attracted to this oxygen. So this one is a special type of dipole-dipole force. So again, that's when hydrogen is attached to either fluorine, oxygen, and nitrogen. This one is hydrogen bonding. Hydrogen bonding. Again here, this one is hydrogen bonding because the hydrogen is attached to the oxygen. So aside from the hydrogen bonding, we also have dispersion force. So dispersion force, this intermolecular force is present in all types of interactions between different particles. Let's proceed to the next one. We have the particles or the molecules of CH4. So CH4, this one is nonpolar. So CH4 is nonpolar. We already have discussed this before. So CH4 is nonpolar. So again, all molecules of CH4 are nonpolar. So the only way that these particles can be attracted to each other is the dispersion of the electrons. So here, again, merong electrons around this one. Let's say most of them are over here on this side. This becomes partially negative, and this part will become partially positive. Let's say the same thing. So this side becomes partially negative. This side will become partially positive. So here, merong different charge. So merong attraction over here. Again, this one is a dispersion force. So dispersion force. So again, dispersion force is between nonpolar molecules. Nonpolar molecules. Next, we have HCl and HI. So H, this one is the electronegativity is 2.1, Cl that is 3.0, then 2.1 for hydrogen, iodine that's 2.5, sometimes 2.6. So as you see here, both of these are polar, right? Because this is more electronegative. This will become partially negative. This will become partially positive. The same thing for this. Unequal sharing. Iodine will become partially negative. This becomes partially positive. So again, let's determine whether it's polar or nonpolar. So this one is polar, and the same thing for this one is also a polar. Again, pag polar, we refer to them as dipole. This is also a dipole. So merong force dito, merong intermolecular force, and this force is known as a dipole-dipole force. So again, just look on what type of molecules are this one. Again, this one is a dipole-dipole force. And again, aside from the dipole-dipole force, meron din siyang dispersion force. Again, dispersion force is present in all types of interaction. Next, we have CH4 and CCl4. Both of these molecules are nonpolar. So the same thing, the only type of force here is dispersion force. Dispersion force. Again, nonpolar. This is also nonpolar. Again, the only source of those charges are the dispersion of the electrons, partially negative, partially positive. Again, merong electrons here, let's say over here, partially negative, then partially positive. Merong attraction. Again, this force is the dispersion force. Next, we have CH3, CH2OH. The shape of this one is something like this. So this one is an alcohol because here we have an OH group. So alcohols are polar. So if we look here, so of course this will be a non-polar on the side. But this is oxygen. The electronegativity is 3.0, while for hydrogen, the electronegativity is 2.1. So this will become partially positive and this side will become partially negative. So this one again is a polar molecule. This one is a dipole. How about the other one? We have this one is the next we have H2O. So H2O, this one is also a polar molecule. Again, this is 3.0. Then hydrogen, this is 2.1. Then 2.1. Partially negative, partially positive, then partially positive. What's the point of attraction here? It's over here, right? Again, partially positive yung H there, then the O here is partially negative. And again, what type of force is this? This is a polar and another polar. Again, pag polar, we refer to them as dipole. So this one is a dipole force. But again, you look into what type of elements are here. This one is a hydrogen attracted to an oxygen. Again, this is a hydrogen bonding. Hydrogen bonding. Next, we have the next one. We have sodium ion, and the other one is H2O. So this one is an ion over here. Then this one is a polar or a dipole. So let's again try to. This is 3.0, 2.1, sorry, 3.5 rather, 3.5. Sorry, that's 3.5 by the way. 3.5 for oxygen. 2.1. This will become partially negative. This will become partially positive, then partially positive. Yung hydrogens, positive, then negative. So this is the point of attraction here. So what type of force is this? This one is an ion. Then here we have this one. The other one is a dipole. So this one is an ion dipole force. Next, we have this one. We have H2O, then C3H8. So this one is a hydrocarbon. So this is made up only of carbons and hydrogen. So when you see this one, this is automatically a nonpolar. So this one is nonpolar. And this one is a polar. Again, H2O is always polar. Partially negative, partially positive, partially positive. So of course, pag polar ito, so this will actually cause the non-polar to become, right? So this is partially negative. So it will actually repel the electrons surrounding this molecule. So it will push the electrons to be here. So this will become partially negative, and this will become partially positive. So now, from a non-polar, so merong formation ng dipole. And again, this dipole is induced by this oxygen over here or by this molecule here. So this one is an induced dipole. So overall, again, merong point of attraction here. This is partially negative and this one is partially positive. Now this type is this one, again, pag polar, that's a dipole. So this one is a dipole. Then the other one is induced dipole. So when you see this nonpolar, this will become induced dipole. Next, last one, we have Mg plus 2, and we have C2H6. So we have here, this one is an ion. This is a positive ion. Then the other one is C2H6. Again, this is a hydrocarbon made up of carbons and hydrogens only. So this one is nonpolar. This one is nonpolar. Nonpolar. This one is an ion. Again, pag merong ion, this will attract the electrons from this one. So since again this is positive, it will attract the surrounding electrons from this molecule. So they will stay over here. This side will become partially negative, and this will become partially positive. So again, before it's nonpolar, but because of this ion here, this will become a dipole. And again, this dipole is induced by the ion. So again, this nonpolar will become an induced dipole. So here we have a point of attraction, positive. Then the other side is partially negative. Now this force is known as ion-induced dipole. This one is ion-induced dipole force. Induced dipole force. Okay, let's summarize everything now. For letter A, the given is H2O. So H2O, this one is polar, and the other is also polar because it's the same molecules. Again, pag polar, we refer to them as a dipole. This is also a dipole. So the force here is a dipole-dipole force. But take note here that we have a hydrogen, then an oxygen. So pag merong ganito, this is actually hydrogen bonding. Hydrogen bonding. Again, hydrogen bonding is a special type of dipole-dipole force we're in. Merong hydrogen, then ang H, it's attracted to either fluorine, oxygen, and nitrogen. Aside from the hydrogen bonding, we also have here dispersion force. Again, dispersion force is present in all types of interaction. Let's proceed to letter B. The given here is methane or CH4. CH4, this one is a nonpolar molecule. So nonpolar is also a nonpolar. So again, pag nonpolar, the only type of intermolecular force here is dispersion. Dispersion force, the weakest force. Let's proceed to the next one. We have HCl and HI. HCl and HI. HCl is polar. HI is also a polar molecule. Again, polar, we refer to them as dipole. And another one is also a dipole. So this one, the force here is a dipole-dipole force. Dipole-dipole force. This is not a hydrogen bonding because here there's no F here or oxygen or nitrogen on this given. Let's proceed. Of course, aside from the dipole-dipole force, we also have dispersion force. Again, dispersion force is present in all interactions. Let's proceed to the next one. We have CH4 and CCl4. CH4 and CCl4. CCl4. CH4 is nonpolar. The same thing with CCl4, it's also nonpolar. Again, pag nonpolar, the force is dispersion force. Letter E, we have ethanol. So ethanol, alcohols are always polar. So this one is a polar molecule. The other one is H2O. H2O again is also a polar. Again, pag polar, dipole, then we have, it's also a dipole here. So this one is a dipole-dipole force. But again, you take note, we have hydrogens and oxygen here. So this one is hydrogen bonding. Hydrogen bonding. And we also have dispersion force. Dispersion force. Let's proceed to the next one. We have sodium ion. And we have H2O molecule. Again, sodium, this one is an ion. H2O is a polar molecule. Again, pag polar, this is a dipole. So the intermolecular force here is ion-dipole force. Ion, then dipole force. Next, we have here G, we have H2O, and then C3H8, C3H8. H2O here, this one is a polar molecule, and this C3H8 is a nonpolar molecule. So pag merong polar na katabi ng nonpolar, this will actually, so this nonpolar will become, so this will eventually be, or it will become an induced dipole. Induced dipole. Okay, so over here, this polar, again, we refer to this one as a dipole. So overall, the force here is, we call this force over here as a dipole, induced dipole. Induced dipole force. Next, let's go to the last one, letter H. So H here, we have magnesium ion, and we have C2H6. This one is an ion. Then this one is a nonpolar molecule. Again, this ion will, so this nonpolar will eventually become an induced dipole because of the ion. Induced dipole. So the force here is, the force for this one will become ion, then the other one is induced dipole. Induced dipole force.